Okay, so in this video, I will briefly talk about the first two homeworks. Okay, uh, so basically, in the homework 1 and homework 2, we only need Excel to do this work. Okay, so and many students, many of you just give me the regression results, but it's ideally you should answer all the separate questions here. Okay. So let's begin with homework 1. And the first question is C2 here, right? So we have data, which is called CEO salary 2, okay? So it contains information on chief executive officers for US corporations, and the variable salary is the annual compensation in thousands of dollars, and the CEO 10 is prior number of years as company CEO. So let me open the data set first, okay? So this is the salary one. Okay, so we have salary and CU10, these two variables, right? So let's see what's the first question here. First, it asks you to find the average salary and the average tenure in the sample, okay? So it's pretty simple in Excel to find this average number, right? So for example, if you choose the whole column, there will be an average here, right? So here, the average CEO tenure is 7.95, okay? Almost 8 years. Uh, 7.95. But if in Excel can also do this average function, right? Choose A2 to A 178. Okay? So it gives you 7.95. Okay, if you do this, so this is the average from B2 to B178, right? And the salary, the average salary is $865,000. Okay, so this is the average number of CEO tenure and salary. So this is pretty simple, right? So how many CEOs are in their first year as CEO? Okay, what is the longest tenure of as a CEO? So this is basically ask you to find. So in Excel you can use this filter and select this CEO tenure equal to 0, right? And we found 1, 2, 3, 4, 5 observations. 5 of here it says 5 of 177 records from. Okay, and you can unfilter it to get the original data, and also ask you to find the longest tenure as a CEO. So you want to find the maximum of this. Okay, so let's find the max of A1 to A178, so which is 37 years. So the longest tenure is almost 38 years. You should add one more year, one more year, because this is how many years prior to this year. So the answer to this question is 37. Okay, simply find the maximum of CEO tenure. Okay, so the last question is ask you to fit the simple regression model, right? Using CEO tenure to explain the log of salary. Okay, there are actually two ways to do this. Okay, so let me do this log of salary. Let me do this MTL salary, which equal to log of salary. So you do a log transformation, right? And double and drag up to the row 178. Okay, so it gives you the log of salaries. And also we need CEO tenure. Okay, CEO 10. We copy this column. We copy the first column to here. So we have two columns of data adjacent to each other, so that we can draw the graph and look at the results of simple linear regression. Okay, so we can do the simple one by simple linear regression by choosing these two columns and insert the scatter plot. Okay, so this is the scatter plot of log of salary, and then we can fit and make it larger. Okay, so I can also I can fit the line trend line here, right, at the trend line, which is basically the regression. Okay, and we choose linear because we have done the logarithm transformation, so we fit it with linear. Okay, and also we choose display the equation on chart. Okay, and display the R square on chart, so that here we can obtain the regression equation and also the R squared. So this y is log of salary and x is tenure, right? So this basically gives you the regression equation. Okay? Okay, this is the simple regression results, and we can do it in another way. Okay, we can simply do use these two columns of data, okay, without transforming the salary data at the beginning, but we insert another scatter plot on this one. Okay, this is another scatter plot, and here there's no transformation of salary. We can also get a trend line, but now we don't choose linear one. Okay, display. Actually, we choose the exponential one. So we obtain this regression equation, and you see the coefficient of x is 0.0097, right? And this is the same as here, 0.0097 here. So for this one, we choose the exponential one because if we log is the exponential of log of salary, right? So when we fit the regression of log salary on CEO tenure, okay. So this is the other way to do regression with log salary. We use fitting the trend line with exponential instead of linear one. Okay. There is another way to do linear regression. Simple linear regression is that's basically use the same methods of multiple regression, which you've already know. So basically, we do choose data and choose data analysis. Okay, and we from here we choose regression, and we use log of salary, L salary, as our dependent variable y, input y. And input x, we choose the F column. Click labels here, and let's just press OK. Oh, one. Now we get the results. We get the coefficients here for the CEO tenure to be 0.0097 to 4 more precisely, and intercept 6.5. If we go back and check this one, 6.5, right? The same. And the better of this method is that we can get more statistics, for example, the t-statistics. So the t-statistics here is one for CEO tenure is 1.5. It's not really significant, and the p-value is about 12.8%. But for just homework 1, we don't discuss these statistics. Right? We know that the r squared is 0.013. Okay. The r squared here is 1.32%. So now we can answer the question here, right? What is the approximate predicted percentage increase in salary given one more year as a CEO? So this is the answer to this question is actually the beta 1 here, right? The estimated beta 1 here. And from here, this number basically tells us that if CEO tenure increased by one more year, if you have one more year on the CEO position, your salary will be increased by almost 1%, right? Point 97%, almost 1%. Okay, so the answer is you can just write approximately 1%. Okay, there's a 1% increase in salary as given one more year as a CEO. So this is this question. Okay, so let's move on to the second question, C3 here. So in C3, we use another data set, which is called Sleep 75, to study whether there's a trade-off between the time spent sleeping per week and time spent in paid work. So whether you sleep less if you work more, right, or the other way around. We would use either variables as dependent variables. For concreteness estimate model, sleep equal to beta 0 plus beta 1, total work plus U. And sleep is the minutes spent sleeping at night per week. Total work is total minutes worked during the week. So the first question here is that to report your result in the equation equation form along with the number of observations and R squared. What does the intercept in this equation mean? So in most of the regression, intercepts do not really have a specific meaning. But here, before reporting the results, we can consider what's the meaning of beta 0, the intercept here, right? So it basically says that suppose the total, if you don't work in this week, so basically your total minutes of work during this work is 0, right? Total work equal to 0, the number of minutes, how many minutes you sleep in this week. So this is the meaning of beta 0. Suppose you are not working this week, how many minutes you spend sleeping in this week. Okay, so this is the meaning of this beta, beta 0, the intercept. Now let's open the data set. Let me close this first. And open the data set on sleep. Total work, sleep, right? And sleep as the dependent variable and total work as our independent variable. And we run the simple regression. And by far, this is exactly similar to what we have done in the previous example. So let me do this quick. So to be more intuitive, I will illustrate the scatter plot. Choose all the data of these two columns and insert the scatter plot. Okay, and let me enlarge it. So in this graph, it's pretty much there is some sort of trend line. The trend line, the trend is kind of more clear than the previous example, previous exercise, right? And let me add the trend line. So when I add the trend line, click display equation on chart and click R squared. The question asks us to report these two things. Right? And get here. this. So here, now we can report the numbers here, right? Beta 0 is estimated to be 3,586. This is the total minutes you sleep if you don't work during the week. Right? And on average, this is how many hours? 3, 5, 8 equal to 3, 5, 8, 6.4 divided by 60 is the hours, how many hours you sleep during the week, right? And on average, 7 days per week, so divided by 7 is, so on average, people sleep 8.5 hours per day, okay? So it's quite long to me, anyway. And the beta 1 hat is negative 0.15. Okay. So this is the estimated result of this equation. And I have explained, right? The intercept means that if you don't work, you sleep 3,586 minutes per week on average. Okay? This is equivalent to 8.5 hours per day. And also it asks you to report the R squared. The R squared here is almost 10%, 10.33%. And the second question, if work increased by 2 hours, how much is sleep estimated to be to fall? Do you find this to be a large effect? How to answer these questions? So basically, we use 2 hours as our input and times the beta 1, right, to get the estimated effect of that total work increased by 2 hours. But here, the total works are measured in minutes. To be cautious here, that total work is measured in minutes. So we have to transform these 2 hours to minutes. Okay, so 2 hours equal to 120 minutes. Right? So it's 120 minutes times the beta 1 here, which is negative 0.1507. That's our negative, the 0.1507. Okay, and it gives you the result, which is 18 minutes. So the answer to this question here, if total work increased by 2 hours, sleep is estimated to fall by 18 minutes during the week. So do you think this effect is large or not, or small effect? So basically, remember that this is the effect on the total minutes of sleeping during the week. So for the entire week, the time that you sleep is reduced by only 18 minutes. So per day, on average, for each day, the total sleep is decreased by only a bit more than 2 minutes. Right? So the effect is actually relatively small. Okay, very small, 2 minutes. And on average, as we calculate, but every day people on average sleep 8.5 hours. So it's a pretty small effect. This is homework 1, and I will do another video on homework 2. And if you have any questions, by the way, if you have any questions, just leave me a message, okay?